Now let's see the equation of a tangent and a normal to the circle. Now, before we dive into this, let me just explain what the tangent and the normal are. So if you draw the coordinate axis, right, y-axis and x-axis, and let's say this is the center of the circle and this is the circle itself, right, and it says that you have this point over here, right, and it says that you have to find the tangent at this point. Then what you have to do is you look at this point and you draw a very sleek line, a straight line. I'm sorry for my art, but yeah, this is a straight line that basically gives you the gradient of the circle at that point, right? So if you took this point over here, right, let's say they ask you to find the tangent at this point, you would draw a line that just touches the circle at that point, and that will give you the gradient of the circle at that point, right? And let's say you have this point, the gradient, the tangent would be like this, and you get the idea, right? And so let's say they told you to find the normal to the circle at let's say this point over here. The normal would be perpendicular to the tangent, so it would be something like this. This would be the normal, right? It's perpendicular. The normal at this point would be something like this, 90 degrees. The normal at this point would be something like this, right? And you may have noticed something. All the normals to the tangents of a circle eventually end up coinciding with the center of the circle. So the normals are technically the radii, right? But the only difference is it's not just limited to the circle, because this line is also perpendicular to the tangent. If you extend the line backwards, this line is also perpendicular to the tangent. If you extend this line, it is also perpendicular to the tangent. But yeah, eventually they all end up at the center. So now that you've covered what the tangent and the normal to the circle are, let's see how you can find the equations for the normals and the tangents. So this is the equation of a circle, right? With its center at -g minus f, right? This is the center, and any point on the circle being x and y. Okay. Now, the equation of the tangent, let's say at an arbitrary x1 and y1 coordinate, well, let's see. This equation will be this. Okay. So, for example, again, let's just draw a circle, right? It's in the coordinate axis, that's just a given. But let's say this is the point, and let's say the coordinates are x1 and y1, and they told you to find the equation of the tangent at this point. So this line over here, you need to find the equation of this line. That can be given by this equation over here, right? So well, what you simply need to do is, let's say this x value is 8 and this y1 value is 11. So all you have to do is replace this 8 in over here and over here, right? And you replace this 11 in the y1 placeholders, so over here and over here. So eventually you'll get the equation of the tangent. And also, let's see how you can find the equation of the normal at this same point, x1, y1. Well, you use this formula, and if you cross multiply, you eventually end up with this, right? Y minus y1 over, if you take this to the denominator on the left hand side, x minus x1 is equal to y1 plus f over this x1 plus g, right? So both of these are equivalent, and you can use this equation to find the normal at this point. So basically this line over here, right, as its normal to the tangent.